In this video, I'm going to try to show how to create a linear model given a set of data. The skills I'm going to try to show are the sort of like fundamental skills, the basic stuff you need to do a full problem and get full credit. So here we're given some data, age of infants, female infants, and then the height. And what we want to do is we want to create a scatter plot where we have the age, didn't do that right, age and height. So we want to plot the points and then evaluate them. So the best way to do that is to put this data into your calculator. So I'm going to go over the calculator commands. I can't easily show that on this screen. I can't show the calculator very easily, but in L1, so you go to your list, and in L1 you put all the X values in. Okay, and there's going to be the last one I think is 9. Okay, and in L2, so X values here, this would be the age. And in L2, you'd put in the height. Okay, so you get your Y values in here. Boom, boom, boom. Okay, so then you want to go to Stat, Plot, and select the scatter plot icon, and just tell it that in the X list you have 1. In X list you have L1, and in the Y list you have L2. And then just say zoom 9. Okay, and you should get a scatter plot. If you don't, if you get some kind of syntax error, make sure that you have the same number of Y values and X values, and also go to the Y equals button and make sure you don't have some kind of information in here, because it could be trying to graph a function. And third, make sure you have all the other graphing things turned off. Okay, so if you do that, you should get a scatter plot, and I tried to do one already. I'm just going to go edit, copy, and then edit, paste. There it is. And so I'm going to just plop that thing in there right here so that we don't spend too much time. Alright, I'm going to wipe out some of my stuff. But basically, there it is. Okay? Let's do this. What I'm going to do is I'm just going to get rid of this. It's kind of ugly. Okay, so now we have our scatter plot. So now we can evaluate it and determine. We do our first check. So what are the conditions for a linear model? So the first thing we want to do is say that, well, we want to say we have 2 quantitative variables, age and height. Okay, so that's a requirement. Then we need a straight enough requirement. And what we might want to say is that the scatter plot shows a, let's just be conservative, a moderately strong positive, because it's going up, linear association between age and height of female infants or babies. What do they say up here? Infants. Okay, so that's the third condition. So this is the requirement, straight enough, and then this is sort of like if you were asked to interpret the form and the direction. The form is linear, the direction is positive, the strength is strong. And we talk about an association yet. It's too early to talk about correlation. The last thing we want to do is talk about unusual values. So we say, we would say there are no apparent unusual values. Okay? So it, let's say it makes sense to proceed with a linear model. Okay? So that's sort of like the first step. Now we're not done checking all the conditions or doing all the checks, but first we need to put a line through this data. We need to put a line through it, and so we can create the residuals. Okay, so the next question is simply do that. So go back to your calculator command and say stat and go to calculate and go to 8 linear, or I think it's LIN, just LIN, regression, and put in L1 and L2. And when you do that, you will get something like this. You should get y equals a plus bx, telling you the form, and it'll tell you that a is 19.39, something like that. B is going to be 0.66, I think it's 77, and then R is 0.91, and R squared is 0.833. Okay, so they ask what is the line, what is the model, the least squares model. So it's the same thing. This, if you see this least squares regression line, so the equation of that, that is a linear model. Okay, so here what we want to do is say height and put a hat on it equals the y-intercept 19.39 plus 0.6677 times the age. Okay, so this is our model, and this is the regression coefficient right here, R, and here is the I think it's correlation of determination, something like that, R squared. Okay, so now that we have the line, by the way, if you were asked to graph the line and you didn't have a calculator, but you have the function, you could just take like 1, plug it in, or you could take, actually 0 would be easier, put 0 in and you get 19.39, so you get a point, okay, right here, and then plug in another number like 9 or 8, plug that in, get another number, put it up here wherever it is, and then take a ruler and draw the line through. Okay, that's another way to get the line. There's ways to get the calculator to do it, but that's not critical. What we really want to do is do the final check for appropriateness, and so that means look at the scatter plot. So the calculator functions to look at the scatter plot are a little involved, so I want to go over them. So what you would do is, remember we have the age in L1. So let's call it X1, X2, down to X9. So in L2, we have the Y values, Y1, Y2, down to Y9. Okay, so what we want to do with L3, we want that to be the predicted values, Y hat 1, Y hat 2, the predicted values from the model. Okay, so that would just be this right here, only we would put L1 in for age. So we would say, go up and put the cursor up here and say 19.39 plus 0.6677 times L1. And that will give you all these values. Okay, so that's all you're doing. So now, if you recall, the residual, one residual is equal to the observed value minus the expected. So notation-wise, we call the residuals E, and we say that E is equal to the Y value minus the expected value. So that's just the value from the equation. So since we have a bunch of residuals, sometimes we put a little I there. Okay. So what we would do, I just have a little bit of room right here. Well, let me do this. Let me take this. I'm going to cut this out for a second. And paste it. I'm just going to put it right there for right now. Okay, so I have room. So this is L3. So for L4, we want this to be E1, E2, down to E9. And where that's going to be Y hat 1, no, excuse me, Y1 minus Y hat 1. And E2 is going to be Y2 minus Y hat 2, and so on. Okay, so that is pretty simple. You have them right here. The Y value is L2, and you're going to subtract off L3. So you just put the cursor up there, do that, and bam, you got your residuals. Okay, so now to get the residual plot, you simply need to go to stat plot. So second stat plot. And it's the same thing. You select the icon for scatter plot, and then the X list is still L1 or wherever your X data is, but your Y list now should be L4 because that's where your residuals are. Okay, now if you do that, you'll get a residual plot. Make sure you say zoom 9 because you'll have to reset the window parameters. And I'll give you a quick residual plot. Should look something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. So our x-axis is there. So I get something like this. I don't know if it's all that important to scale it. You can if you want. You get something like that. And then I go over 1, 2 to what? I go over 2, down here, something like this. Okay, something like that. I might be a little off here, but that's what it shows. Okay, so what we're interested in is do you see a pattern? So what we would like to see on the residual plot is no pattern at all. We'd like to have lots of data and the data spread out all over and we see no pattern at all. What would be bad is if we see something that sort of indicates some curvature that we were not able to see on the scatter plot. Okay, something like that or something like this. This would definitely not be good. Okay, so we see a pattern. The other kinds of patterns that we don't like is if it starts out real tight and then all of a sudden it fans out like that. It kind of fans out. So we see a fan out or a fan in. If it's tight like this and then all of a sudden, or it starts with lots of variability and then it fans in. These would all be considered having a pattern, and so we would probably have to stop. This is not good. We would need to stop. This is what we hope to see. So here it looks pretty good. Okay, it'd be nice to have more points, but it looks pretty good. So we'll say something like, and just be explicit, the residual plot shows no apparent pattern. So a linear model is appropriate. Okay? Now I'm going to stop this video here after saying a couple other things, and then I'll come back for part 2 and we'll describe the model. But I want to go back up and talk about one more thing real quick. Remember when we said there are no apparent unusual values? So I just want to talk real quickly and say, okay, an unusual value could be an outlier way down here. Now you may recall that an outlier like this, close to maybe x bar, the average value in the x direction, this will have very little impact on the model. It won't really move the line wherever it is. Same thing with an outlier up here. So you should point them out, but it still would be okay to proceed. Okay, so because these are points that don't have much leverage, they're very close to x bar. Another point that we might not be concerned with is, let's say we had a point way out here for some reason. Well, it kind of follows the line that we would get right here. So if we remove that point, even though it does have lots of leverage, if we remove that point, it's not going to change the model. So you would note that there's an outlier, but we could still proceed. Where we want to be careful is, let's say we have an outlier over here somewhere. Now what's going to happen is, because it has leverage, because it's way over, a long ways away from x bar, the line's going to get pulled down. So the line's not really going to be representative. Well, it is, but it's being pulled down by this outlier. If we remove this outlier as a test, the line would pop back up. So now we have an outlier that has a lot of influence, and that's bad. There, it might be inappropriate to proceed. You'd need to investigate the outlier and try to figure out why it occurred. Same thing with an outlier over here. It would pull the line up this way, or in this direction. It would pull it this way. So we would get a different model than what we can kind of anticipate. Alright, so in those cases, you would not proceed, and if you have a pattern in the residual plot, you would not proceed. Okay? Alright, that's the end of this video, and good luck. Watch the next one.